Okay, so now we're going to talk about rotational symmetry. So, kind of like reflectional symmetry, it does involve putting something back onto itself. But with reflectional symmetry, you drew a line, and it would fold back onto itself. Rotational symmetry, it's essentially how many times can you turn this guy counterclockwise and have it be back onto itself. So that's what rotational symmetry is. So, how many times can you turn the object back onto itself? So when it comes to this, you can kind of count the sides again. So like for hexagon, how many times is it going to rotate back onto itself? Well, count the sides. That's how many times it's going to rotate onto itself. So you got 1, 2, 3, 4, 5, and 6. So it rotates back onto itself 6 times. For this cross here, or whatever you want to call it, it's whenever the big flat pieces touch each other again. So that's 1, 2, 3, and 4. And for this kind of unlogated star, it's whenever a point is going to be pointing up again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 4 and 10. But we're not finished with that. So what we're going to do is we're also going to take and find what's called the smallest angle of rotation. So all circles are 360 degrees. So when you rotate counterclockwise, you go 360 degrees. Well, every time it stops, that's an angle, a smallest angle of rotation. So how do you calculate that smallest angle of rotation? Well, you take the number of times it's going to stop onto itself and divide it into 360. So I'm going to take 360 and divide it by 6. And that gives me 60 degrees. And what that says is the smallest angle of rotation that rotates back onto itself is going to be 60 degrees. So the next one, I'm just going to do 360 divided by 4. So that gives me 90. And then 360 divided by 10. And that gives me 36. And those are my smallest angles of rotation. Now, what if I want to apply this to, say, rotating something outside of a coordinate plane? Like the last time we did it was just rules based off of coordinate planes. Well, we can do this. So what I'm going to do here is this. I'm going to look and say, well, this thing has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So its smallest angle of rotation is going to be 360 divided by 10, which gives me 36. Okay. So what is the angle of rotation that will make A the image of E? So we want A to be the image of E. So when we look at this, my pre-image is going to be E, and my image is going to be A. So basically, I'm going to start at E and go towards A. So if I look up here real fast, if I start here at E, I'm going to count how many times it takes me to get to A. 1, 2, 3, 4. So that's 4 times. I'm going to take that 4, I'm going to multiply it by my smallest angle of rotation, which is 36. So I do 4 times 36, and that gives me 144 degrees. So that means the angle of rotation that makes A the image of E is 144 degrees. And now we're going to keep doing this kind of thing. So what will make B the image of C? So once again, you have the pre-image. I'm going to just abbreviate that to PI. And you have the image. The pre-image is going to be C because B is the image. And so we're going from C to B. This one's not too far. We go up here, here's C. We go up to B. That gives me a whole whopping 1. 1 times 36. Well, it's going to take 36 degrees to get there. What is the angle of rotation that makes F the preimage of D? So you gotta be careful, we switched words here. So now F is the preimage, so the preimage was going to be F. And the image is going to be D. And so we're gonna start at F. We're gonna go 1, 2 to D. 2 times 36 is 72 degrees. Okay. Once again, we're going to make H the preimage of A. Preimage, so H is the preimage, A is the image. Once again, we're going to go around to, so from H, 1, 2, 3, 4, 5, 6, 7 to A. 7 times 36 is, let's see, well, 5 times 36 would have been 180, and so 2 more would be 72. So 180 plus 72, that would be 252. What is the angle of rotation that will make C the image of B? So now B is the preimage, and the image is C. That's going to be, so if I'm going to B to C, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 36 is 324. Good. Let's see. Let's turn the page. If I can get it turned. There we go. All right, we got one more for this one. So 6. I want the angle of the rotation to make D the image of A. So D is the image, A is the preimage. So A is going to D. And so A going to D, we got 1, 2, 3, 4, 5, 6, 7. We're always going counterclockwise. So 36 times 7 is going to be, once again, 252. Hike. Football joke. Terrible football joke, I know. I think it's actually blue 52, but whatever. Alright, so it sounded right. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we do the same thing here. 360 divided by 12. That's going to give me a whopping 30 degrees. Okay. What is the angle of rotation that makes A the image of E? So A, once again, is the image. A is the image of E. So we're starting at E, and we're going to A. So 1, 2, 3, 4. 4 times 30 gives me 120. What is the angle of rotation that makes B the image of C? Again, we're going from C to B. Not a very far place. We go 1. 1 times 30 is 30. What is the angle of rotation that makes F the preimage of D? So once again, in this case, we're going F to D. So 1, 2. What is the angle of rotation that makes H the preimage of A? So H is the preimage, so we're starting from H and going to A. 1, 2, 3, 4, 5, 6, 7. So 7 times 30 gives me 210. Okay, and then if I pull this out, I got 2 more here. What is the angle of rotation to make C the image of B? So C is the image, so we're going from B to C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You never count the first one, B first. So that's 11 times 30, which gives me 330. And then what is the angle of rotation that makes D the image of A? So starting with A, going to D, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 30 equals 270. Okay. And then I got one more here, nice one. I wanted to do this one too because it's got 2 slightly different questions. Now there's 24 going around. Trust me, I know, I made it. So 360 divided by 24. So let's see. I'm having a brain fart right now. 15 degrees. Okay. So what is T under 195 degree rotation around Z? So this is slightly different than what we've seen so far, but it takes the same idea. You're going to take 195 and divide it by 15. 195 divided by 15 is 13. And what that's going to do is start at T and go counterclockwise 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So G is that thing. Then, what is M under 165 degree rotation around Z? So, same thing, I'm going to take 165 and divide it by 15. And that's going to give me 11. So M, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 gives me B. What is the angle of rotation? It makes R the image of F. So, same thing before. R is the image of F. So F is the preimage, and I'm going to R. So here's F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 15. Just double check that real fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 it is. So it's 12 times 15. That gives me 180. Okay, what is the angle of rotation that makes N the image of S? So, same thing. N is the image, so we're going from S to N. So 1, 2, 3, 4, 5. So we get 5 times 15, which gives me 75. Okay. And then, just switch this out real fast. What is the angle of rotation that makes M the preimage of X? So, M is the preimage, so we're going from M to X. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 times 15. And let's see, that's going to give me, I'm going to cheat a little bit, 195. Okay, and then X to V. X is the image, V is the preimage, so we're going actually V to X. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 times 15 equals 330. And that's how that's done.